All right, IM2 classes. We are working on inverse functions. So an inverse relation switches the input and output. So remember that, what you want to think about is that word inverse, like invert, right? What do you do if you go inverted, right? You go upside down, you flip upside down. So all we're doing with inverse functions is we are flipping them. Inputs become outputs, or x's become y's. Remember from IM1, x's become y's. So, uh, so here, looking at this example of just ordered pairs, the x, so -4 is an x, and the inverse function becomes a y, 7 is a y, inverse function becomes the x. You're just flip-flopping them. Or if you have them in a table like this here, the inputs go down and become the outputs. And then the outputs in the original function go down to become the inputs. That's all you're doing. You are inversing them, you are flipping them, flipping the x's and y's, or the inputs and outputs. So let's write an inverse function ourselves. So -3, -4, we flip that. -4 becomes the x, -3 is the y. Fix that line, don't care. 0, -2, so that's 0, -2. -1, 4 becomes 4, -1. 0, 8 becomes 8, 0. 12, 1 become, or 1, 12 becomes 12, 1. 2, 16 becomes 16, 2. And 3, 20 becomes 20 and 3. Just flip the x's and y's. All right. A reminder, x, y. So this becomes, you're just flipping the x and y. All right, let's look at it for the table. So if we have a table, why do they do it like that? Fixing this. I'm gonna make a table. So I have an input and the outputs. Nope, not what I wanted. So these numbers are going to go down on the bottom here. So the inputs become the outputs. And then these numbers go on the top here. So 4, 1, 0, 1, 4. Make sure you line them up. I didn't put in the boxes, but it's lined up there. All right, next example, we have input and output. We're going to do in a mapping diagram. So something else you might remember from IM1. So the outputs become the new inputs. So that's going to be 9, 1, 4 over here. And then our new outputs. Yeah, fix that line because it's all right. All right, -3, -1, 1, 3. All right, and a lot of kids, I know you like to just leave the diagram like that. It doesn't work. You have to do the mapping arrows. So here, an input of 3 gives you an output of 9. So that means the input of 9 gives an output of -3. -1 goes to 1, and 1 goes to 1. So this one here is going to have two outputs. It's going to have an output to -1 and an output to 1. And then this one here, you do have to put the lines. Notice that this one, this inverse, is not actually a function. For a function, your inputs can only have one output. You can have multiple inputs going to a single output, but you can't have one input with two outputs. That's not a function. All right. There's assignment from the book, and moving right on. So here, we are going to find the inverse algebraically. So solve for y equals f of x for x. then find the input. So all we're doing is finding the inverse. First thing I'm going to do is make this a little bit easier to read. I'm going to get rid of this function notation. I'm going to change the f of x to a y. And then the line of separation to help with solving, I'm going to solve for x. So solve for x, I'm going to add 6 to both sides. And you get y plus 6 is equal to x. This cancels out here. And there we go. We have solved for the inverse. So there is our inverse. So switch to f of x for y, solve for x, you're done. Sometimes it's easier to read it if we write it like this. All right. And then here, find the input when the output is 2. So I'm going to write my inverse function over here. What this means is this is going in for y. That's all. And so you get x is equal to 2. I wanted that in green. So changing the y to a 2. Plus 2, you get x is equal to 4. So for our function, when x is in the original, when x is 4, y is, what the heck did I just do? No, that's not, this is a 6. What the heck? This is a 6, this is an 8. I don't know, I wrote the function wrong here, right? My bad. I don't know what I was thinking. Yeah. Anyway, now that looks better. So when the output is 2, the input is 8. Here, let's do another one. First thing I'm going to do, change the f of x to a y. So I don't have to keep writing f of x. And I am going to solve for y first, or excuse me, solve for x. First thing I'm going to do is solve for x. Subtract 3 from both sides. So on this side, I get y minus 3 is equal to 1/2 x. Fix that. Now the 1/2 x, this will trip kids up a little bit. You can divide by 1/2, but that's going to get confusing over here. We need to remember dividing by a fraction is the same thing as multiplying. So on this one, what I'm going to do is actually multiply both sides by 2. Multiply both sides by the denominator. What that does is that cancels out. 2 times 1/2 is just 1. That all cancels out. And so I get 2. Actually, I'm going to distribute the 2. 2 times y is 2y. 2 times 3 is -6. There. All right, I'm going to rewrite it up here. X is equal to 2y minus 6. Wrote it correctly this time. And then find the input when the output is 2. So again, I'm going to just take this and substitute it in the y there. So it's going to be x is equal to 2 times y minus 3, and y is 2. So evaluate that. 2 times 2 is 4, minus 3. 4 minus 3 is 1. Oh my God, why does it do that? That has got to be the most annoying thing. There we go. All right. We're going to skip ahead. I'll do that example in class, but put in x for f of x, or y for f of x, solve for x, and then input, put in 2 for the y, and figure that out. So there's the assignment here. Now we're to graphing. So it says graph the inverse, or find the inverse, then graph the function and its inverse. I'm going to graph the function first, get that out of the way. So f of x equals 3x. First thing I'm going to do is identify the slope. I'm going to attach the x. So the slope is 3. Slope is easier fractions. I'm going to make it 3/1. I'm going to put a plus. There's no B at the end of it. There's no zero. Well, there's no B, so it means B is 0. So the starting point is at 0, 0. At that point, and then from the slope, it's I'm going to go up 3, right 1. So put a point, up 1, 2, 3, right 1. Put a point, up 1, 2, 3, right 1. Oh, and it doesn't like it when I put points, which is weird. Stop it. Stop it. When maybe do I need to do, I want to, oh my, Anyway, all right, there we have 3 points. This is going to really test my patience. So here I'm going to go down 1, 2, 3 to left 1 opposite direction, and that point disappeared. Oh my God. Oh geez. Um, there is a point. Oh, okay. So here I'm going to connect the dots. So there is the original function. So now I'm going to find the inverse. I'm going to substitute. I'm going to change f of x to a y equal to 3x. I'm going to solve for x. So to solve for x, I'm going to divide both sides by 3. So I'm going to get y over 3 is equal to, that cancels out, equal to x. All right. I'm going to flip-flop those. So x is equal to, instead of y over 3, so you make it easier, is 1/3 y, right? And because we don't like graphing with that, I'm going to flip the x and y back around so it's in a function form that we can actually graph. So there we go. I'm going to graph this. So here is the inverse function. I just rewrote it so that the messy stuff, the fractions is on the right side. That's how we're used to seeing it in y equals mx plus b form, slope-intercept form. And then I flip-flop the x and y just so we can easily identify the slope and y-intercept. So do this one in blue. The slope on this one is 1/3. The y-intercept, again, this one on the y-intercept. So this one also starts at 0, 0. So I'm going to put a point here. Oh my, don't. Hmm. Okay. Then I'm going to go up 1, right 3 from that point. So up 1, 2, 3. I need to change some settings here. I know this is hard to see. This is driving me nuts. Okay, and it's disappearing. So that's all I'm going to put because something's going wrong. So I'm just going to graph it. So there we go. There's our function. All right, let's try one more because that was ridiculous. All right, I'm going to try my best to graph this one in black. So the slope on this line is -3. And make it a fraction. The slope's easier as a fraction. The y-intercept is negative, or the b value is -2. So that means the starting point is at 0, -2. So I'm going to start at 0, -2. That's here. And then I'm going to go down 3, right 1. So down 1, 2, 3, right 1. Ran out of space, so I'm going to go the other direction. Up 3, 1, 2, 3, left 1. Yeah. Okay. Then I'm going to connect the dots with a straight line. Why'd you disappear, point? Why? All right, here we go. I'm going to change the f of x to a y. We get negative 3x minus 2. I'm going to solve for x now. This one's going to suck. Okay, well, add 2. Get y plus 2 is equal to negative 3x. And then I need to divide by 3. And we get y plus 2 minus 3 is equal to x. All right, I'm going to rewrite this. So make some space over here. So it's going to be x is equal to, I'm going to write this as a fraction. It's going to be y over 3 plus 2 over 3. And then I'm going to rewrite the y over 3 as 1/3 y. And now I'm going to switch the x and y. So it's going to be y is equal to 1/3 x plus 2/3. There we go. So this is the function we are going to graph now. So here's the tricky part. The slope is 1/3. The y-intercept, the b value is 2/3. So our starting point is 0, 2/3. That kind of sucks, right? Graphing 2/3, we can do it somewhere here. But it's going to be a messy line. So what I'm going to do is what I know about inverse functions. So the point of this function, our inverse, actually I have it written down up there, so I'm going to keep that one. The starting point on this one is negative 0, negative 2. So the inverse point, I can just switch that x and y to be negative 2x. And here, I'm going to use this as my starting point instead of this fraction. So I'm going to go negative 2, 0. That's going to be here. No, no, stop it. Stop it. Oh, okay, we got a point. And now I have the slope here. So I'm going to go up 1 to the right 3 from that other starting point. So again, I did the inverse of the other starting point. Now I'm using the slope. So up 1, right 1, 2, 3. Oh my God. And you know what? I'm just going to do 2 because this board is driving me nuts today. And we need to pick something. So there we go. So if you get a messy starting point like we got down here, go ahead, you can just use the inverse of the point here. You can actually plot the whole line by just doing the inverse of the points if you want. But I think sometimes just getting a starting point using the slope is a little bit easier. But that is going to do it for today.